Welcome to Mathematics. In this video, we'll be solving the Edexcel IAL January 2024 paper of P3. On to question 1, we are given a point and it lies on y equals to f of x. Now we have to deal with the change in this point due to the transformation applied. In part A, we have y equals to f of 2x. If f of x has p minus 4 comma minus 3, in f of 2x the value of y and the value of x would be halved, so p prime over here will be minus 4 by 2, so minus 2, and the y value will remain unchanged, so minus 3. So the answer to part A is minus 2 minus 3. In part B, we have two changes, one in the value of y, one in the value of y and another in the value of x. So in the value of x, we'll plus 1, so minus 4 plus 1, so we'll get double prime minus 4 plus 1 would be minus 3, and the value of y would be tripled, so minus 3 into 3 is minus 9. Part B is minus 3 minus 9. In C, we have the modulus of f of x. So at x equals to minus 4, y will be 3. So minus 4 comma 3. On to question 2. There is this quintic curve over here, and we have to use numerical methods in this question. We have to show that there is a root in the interval 2 comma 3. So we have f of 3, f of 2 at first, so f of 2 to the power 4 minus 5 into 2 square plus 4 into 2 minus 7, which would be minus 3. F of 3 would be 3 to the power 4 minus 5 into 3 square plus 4 into 3 minus 7, which would be plus 41. Then we can write the conclusion that since there is a change in sign from minus 3 to 41, so if we have a rough sketch of the graph, like even if it was like this would be minus 3 and this would be plus 41. So the graph must cross the x-axis to go from positive to negative if it is continuous. We'll write this conclusion down. Now we have to show that f of x can be written like this. We have f of x equals to x to the power 4 minus 5x squared plus 4x minus 7. Before we go to B, we should also write the part about the continuous function over here, because in case of 1 by x, there will be a change in sign from this to this, but there is no root in between because it's not continuous. Right. There is a change in sign and the function is continuous. If we move up and see this equation, we have to show this. This doesn't have this term over here. So it has 5x square, 4x and 7, but it doesn't have x to the power 4. So it's the subject over here. So x to the power 4 equals to 5x minus 4x minus 7. We basically moved this to the right. Now we can divide both sides with x. So we'll get 5x square minus 4x plus 7 divided by x, and x cube on this side. We took x cube on this side because there's a cube root over here. So x is cube root 5x square minus 4x plus 7 by x. Now we are using this as an iterative formula, and then we have to start with x1 2. We have to at first find x2 to 4 decimal places and then find alpha, the root. So C1, the iterative formula is xn plus 1 equals to cube root 5x square minus 4x plus 7 divided by x. We are given that x1 is 2. So x2 would be cube root. We'll have 5 into 2 square minus 4 into 2 plus 7 by 2, which would be 2.1179. We want the values to 4 decimal places, so this would be the value of x2. Now in part 2 we'll continue. So x3 would be 2.14684. I'm looking for the answers to 4 decimal places, so I'll take one more while I'm working out. x4 would be 2.15406. x5 will be 2.15586. x6 will be 0.19. We'll continue until we see that consecutive values have the same value up to 4 decimal places. So these two up to 4 decimal places don't have the same values because this will round up to be 2.1565. Now we have few values which all round up to be 2.1565 to 4 decimal places. So alpha will be 2.1565. Another calculator tip would be to write the equation down in the calculator and then solving it. So the equation was cube root, and then we had 5x squared minus 4x plus 7 divided by x. Then we press calc. The value of x initially was 2, so 2 will get the value. So then we calculate and then press the answer, then calculate. This is the value of x3, and we'll keep repeating this until this is x4. So if we continue, we'll keep on getting more values of x until we get our answer. So using this function in calculators would save a lot of time in your exams. And that's it for question 2. Now in question 3 we have a logarithmic function and we have to write it in an exponential form. So we can move the power up. So d equals to 10 to the power 1.04 plus 0.38 t. So we can write this down as 10 to the power 1.04 multiplied by 10 to the power 0.38, all of it raised to the power t, or this was what we got. So we can take t out and make it the power of the whole stuff. Now we have to give this to 4 significant figures. So 10 to the power 1.04 to 4SF will be 10.96, and 10 to the power 0.38 would be 2.399. So these are the values. That's it for part A. In part B, they say that when t equals to t, the total amount of money raised is 45,000. So total amount raised in t months is pounds d. So this is the value of d. D is 45,000. D equals to 45,000 when t equals to t. So we can place it in the equations. 45,000 equals to 10.96 times 2.399 t. Now 2.399 to the power t will be 45,000 divided by 10.96. So t will be log 45,000 by 10.96 base 2.399. We need this value to 3 significant figures. this will be 9.51. Now it says that the charity aims to raise 350k within the first 12 months of monitoring, and we have to determine whether according to the model the charity will achieve its aim or not. We could take multiple approaches for this question. One of the approach would be to find the time at which they finally make 350 grants, or the amount they make in 12 months. I prefer the latter method for this question. So D equals to 10.96 into 2.399 to the power 12. So the value we'll get is 398,266, which is greater than 350,000. So we can say that the charity will meet its according to the model. Now on to question 4. We have to show that this function over here can be written as in this form. So question A, let me copy the question. If we check the roots of this equation over here, this quadratic, we'll find that this can be factorized in this form. So 3x minus 5 times x plus 4. So we'll write that down over here. So 3x minus 5 x plus 4. So this and this is common. These are common over here. We can take a common denominator, 3x minus 5 times x plus 4. And for the numerator, we'll have 2x square minus 32 plus 8 times x plus 4. So we'll get 2x square minus 32 plus 8x plus 32. The 32's cancel out, and we have 3x minus 5 times x plus 4 over here. We'll have 2x square plus 8x, 3x minus 5x plus 4. Now the term on the top, this, we can write it like this, 2x x plus 4. Let me do that. If I do this, we can cancel the 2x plus 4 out. So I'll be left with 2x divided by 3x minus 5. And this is what we were told to show. So we have done that. Now we have to show that this is a decreasing function. So a decreasing function means it has a negative gradient. So we can say that f of x is less than 0. So we have f of x, which is 2x divided by 3x minus 5. Since the power of x on the denominator and numerator are the same, we'll have to use long division at first. So 3x minus 5 by 2x. So we'll have 2 by 3 over here. We'll have 2x minus 10 by 3. So we'll have 10 by 3 here. So f of x will be 2 by 3 plus 10 by 3 divided by 3x minus 5. So f prime of x will be 10 by 3 3x minus 5 whole square times 3, and you'll have a minus here. If I show some more steps, this is f of x is 2 by 3 plus 10 by 3 times 3x minus 5 to the power minus 1. So f prime of x will be 0 plus 10 by 3. We'll use the chain rule here, so 3x minus 5 to the power minus 2 and a minus 1 over here. So minus 1, 3x minus 5 to the power minus 2, and we'll differentiate 3x minus 5 and multiply it here, so 3. The 3 here and 3 here cancel out, so f prime x is minus 10 by 3x minus 5 whole square. Now to show that this is a decreasing term, we can show that 3x minus 5 will always be positive because this is squared. As 3x minus 5 is squared, this must be positive. The denominator is positive, and so the whole thing, so 10 by 3x minus 5 whole square must be positive. So minus 10 by 3x minus 5 whole square must always be negative as well. This is the case if x is real. Now we have another function g of x. We are given its equation now, and we have to find the inverse. So y equals to 3 plus 2 ln x. To find the inverse, we flip x and y. So and then we take y as the subject again. So 2 ln y equals to x minus 3 ln y equals to x minus 3 by 2. Therefore y equals to e to the power x minus 3 by 2. Therefore g inverse x would be e to the power x minus 3 by 2. And in the final part of the question, we have to find a for which GFA is 5. So GFA is 5. So let's find GFA. F of A would be 2a divided by 3a minus 5. So we'll have 2a divided by 3a minus 5, and g of x is 3 plus 2 ln x. So 3 plus 2 ln 2a by 3a minus 5 will be 5. 2 ln 2a 3a minus 5 would be 5 minus 2, 5 minus 3, which is 2. We can cancel the 2 out. Therefore ln 2a divided by 3a minus 5 will be 1. So we'll get this 2a divided by 3a minus 5 will be equal to e. To a equals to e to the power 3a minus 5. So 2a equals to 3ea minus 5e. If we bring this to the right and this to the left, so bring all the terms that contain a to the right, because we need to find a. We have to make a the subject over here, so we'll get 5e on this side and 3ea minus 2a. So 5e would be 3e minus 2 over here. Now we can find a, which would be 5e divided by 3 minus 2. And we needed the exact value, so we don't have to find an approximation for this. Now on to question 5. We are given an exponential model over here for the temperature T after T minutes after a heat source is switched off. We are given the initial temperature, the temperature at which the heat source was switched off. So this was the initial temperature. So at T equals to 0, T equals to 18. So at when small t is 0, big T is 18, we can put it in the equation. So 18 equals to 10 plus a e to the power 0, so which is 1, so 10 plus a. Therefore a would be 18 minus 10, so a is 8. Now in part B, we are given exactly 45 minutes after the heat source was switched off, the temperature was 16 degrees. So we have to find the value of B over here. 16 is to 10 plus 8 e to the power minus B, and the value of T is given as well. So 8 e to the power minus 45b will be 6. We can take the 8 to that side, so e to the power minus 45b will be 3 by 4. We can take ln on both sides, so we'll have ln e to the power minus 45b. Ln e is 1, so we'll have minus 45b on this side and ln 3 by 4 on this. B will be ln 3 by 4 divided by minus 45. And we have to find this to 3 significant figures, which I get 6.39 into 10 to the power minus 3. Now in part C, we have to use the values of A and B. The rate of change of the temperature, so d capital T by d small t, at exactly 2 minutes after the heat source was switched off, giving our answers to degrees Celsius per minute. So T was 10 plus 8 e to the power, we can also write this like this, 0.00639 minus 0.00639 t. So dt by dt will be 8 times minus 0.00639 e to the power minus 0.00639 t, where at t equals to 2, the small t, time being 2 minutes, we have to find the rate of change. So dt by dt will be 8 times minus 0.00639 times e to the power minus 0.00639 times 2, which will, if we calculate this, we'll get minus 0.0505 degrees Celsius per minute. Now we have to find, according to the model, why the temperature of the room cannot fall to 5 degrees Celsius. So T can go on and on, so T can reach infinity, so we have to use that as a limit. So capital T will be 10 plus 8e to the power minus 0.90. So we have to find, if we want to find the long-term value of T, we'll have to use limit T goes to infinity, 10 plus 8e to the power minus 0.00639. Now if T was infinite, this will become minus infinity. This is 8e to the power minus infinity. If we draw the graph of e to the power minus x, this is the graph we get. So as this is e to the power minus x, so as the value of x becomes larger and larger and goes close to infinity, the value of e to the power minus x gradually becomes near zero, almost becomes zero. It's asymptotic. So we can write, in the next line we can write T long term value would be 10 plus 8 into 0, so T equals to 10. So this is the lowest temperature we can get. So we can, the temperature cannot fall to 5 degree. So the lowest temperature is 10 degrees Celsius. So the air cannot become 5 degrees. Now we move to question 6. We are given this graph over here of e to the power 3 sin x times cos x. We have to state the coordinates of r. So r is this point over here. R is the second root. So this is the first root and this is the second root. Now we know that 2e times 2e to the power 3 sin x cannot be 0. So this will not be equals to 0. So the root is due to cos x being 0. So at the roots, cos x will be 0. Cos x is 0 when x is pi by 2 and 3 pi by 2. So this is the root at pi by 2 and this is the root at 3 pi by 2. So the coordinates of r would be 3 pi by 2 comma 0. Now it says that there are two turning points at P and Q, and now we have to show that at points P and Q there will be this equation followed. Okay. For turning points, these are stationary points. These are stationary turning points, so for them dy by dx will be 0. So we'll have to differentiate f of x. So f of x is 2e to the power 3 sin x times cos x. We'll have to use the quotient rule, so we'll consider this as u and this as v. F prime x will be v du by dx plus u dv by dx. V is cos x Now du by dx, so u is 2e to the power 3 sin x. So du by dx will be 2 times the integration of 3 sin differentiation of 3 sin x, which would be 3 cos x times e to the power 3 sin x. So we'll get 6 cos x e to the power 3 sin x. So cos times 6 cos x e to the power 3 sin x. U is 2e to the power 3 sin x, and dv by dx will be minus sin x. So we can just move the minus out here. We'll get 6 cos square x e to the power 3 sin x. We'll have to set this equal to be 0 because p and q are stationary points. Now instead of cos square, I'll have to write 1 minus sin square because the equation we have to show doesn't have any cos in it. So we'll only use sines. There will be no cosines over here. So we'll have minus 2e to the power 3 sin x times sin x. Oh, missed something. This will be 3 sin x. We can take the e to the power 3 sin x out of here. So e to the power 3 sin x. Inside the bracket we'll have 6 minus 6 sin square x minus 2e to the power 3 sin x 2 sin x. You can move that out. We can also move a minus outside, so we'll get a plus sin square, and the equation will be 6 sin square x plus 2 sin x minus 6 equals to 0. So this is A, this is B, and this is C. You can also flip this. You might also get A equals to minus 6, B equals to minus 2, and C equals to 6 as well. Now we have to find the x coordinates of point Q. So point Q is the second stationary point. So P is the first one, Q is the second one. We have to find the second turning point. So we can consider any variable. So I'll take y equals to sin x. So we'll get a quadratic 6y square plus 2y minus 6 equals to 0. We can factorize this. We'll just use the binomial formula over here. So minus b, so minus 2 plus minus root over 2 square minus 4 times 6 times minus 6 by 2 divided by 2 into 6. So y will be minus 1 plus minus root 37 by 6. So sin square x will be minus 1 plus minus root 37 by 6. However, minus 1 minus root 37 by 6 is minus 1.18. The range of sin square is from 0 to 1. So 0 to 1. This is outside that range. Sin square cannot be negative, and it cannot have a magnitude more than 1. So we cannot take the negative one. So this will be the answer we take. So we'll get sin x equals to root over minus 1 plus root 37 by 6. So sine inverse (0.37) 90395. So x will be the basic acute angle for this case will be is it in degrees or radians? It's in radians. So the basic acute angle will be 1.169 radians. What we have to give it to 3 decimal places. Okay, so we have to take more values. We'll take one more than what we have to answer in, so 4 decimal places. So x is this is, since this is a sine curve and this is positive, so this thing is positive over here on the right, so it will be in the first and second quadrant. So x will be 1.1691 and pi minus 1.1691. Since q is the second root, this will be the value we want. So this is the value we'll take. So at q, x equals to pi minus 1.1691. We just have to find the x coordinate. So we'll just write the value of this down, which would be 1.973 to 3 decimal places. So that's it for this question. Question number 7 is about calculus. It has both differentiation and integration involved. We have y given, so y is 16 by 9, 3x minus k to the power minus 1. So dy by dx will be 16 by 9 times minus 1. Now we have to use the chain rule, so 3x minus k to the power minus 2 times 3. So this will become 3. We'll have minus 16 by 3 times 3x minus k to the power minus 2, or 16 by 3 times 3x minus k whole square. This is question part A. Now in part B, we are given that the point with x coordinate 1 lies on C. We have to find that we are also given that the gradient of the curve at P is minus 12. We have to find the two possible values of k. So at P, the detail we are given is the x coordinate is 1, and when this is the case, the gradient dy by dx is minus 12. So we can place this in the equation we have found in part A. So dy by dx minus 12 equals to minus 16 by 3, and you'll have 3 minus k square. You can cancel out the minuses, move 16 by 3 to the other, move 12 to the other side, and 3 minus k over here. So 3 minus k square equals to 16 by 3 into 12. So you can expand this. So 9 minus 6k plus k square equals to 4 by 9. Now we'll solve this quadratic. So k square minus 6k, and then you'll have 9 minus 4 by 9. So 77 by 9. You'll have k equals to 11 by 3 and k equals to 7 by 3. So these are the values of k. This is part B. Now we are given that k is less than 3. So 11 by 3 would be 3.67. So this is out. So now we are given that k is 7 by 3. So at part C, k is 7 by 3. We have to find normal to the curve C at point P. So P is 1, comma. Now we can find the value of y. So this is 7 by 3. The value of y will be 16 divided by 9 times 3 minus 7 by 3. So we'll get 8 by 3. This is P. At this point the gradient would be, we are already given that, minus 12. So this is the gradient to the tangent. So the gradient of the normal will be minus 1 by minus 12. So this will be positive 1 by 12. So the equation of the line will be y minus y1, which is 8 by 3. This is x1, this is y1. So y minus 8 by 3 equals to 1 by 12 x minus x1, so x minus 1. We have to give it in this form. So y minus 8 by 3 x by 12 minus 1 by 12. Move everything to the right. So x by 12 minus y minus 1 by 12 plus 8 by 3 equals to 0. We can multiply the whole equation with 12, so you'll get x plus x minus 12y plus 31 equals to 0. Now in part D we have to show that 16 divided by 9 into 3x minus k is lambda ln 10, where lambda is a constant we have to find. So this is the integration. 1 to 3 the value of k would be 7 by 3 dx. The integration for this, we can take 16 by 9 outside at first. So 1 3 1 3x minus 7 by 3 dx. To integrate, we need this in this form. So f prime x so we have to introduce a 3 over here. So we have to multiply 1 by 3 here. We'll get 16 by 27, and inside we'll get ln 3x minus 7 by 3 from 1 to 3. So 16 by 27 times ln 3 into 3 minus 7 by 3 minus ln 3 minus 7 by 3. 16 by 27 we have ln 20 by 3 minus ln 2 by 3. So 16 by 27 times ln, will take all of it inside a single logarithm. So 20 by 3 divided by 2 by 3, which is 10. So we'll have 16 by 27 ln 10. So this is lambda. So lambda is 16 by 27. That's it for question 7. Moving to question 8. This is a question about modulus. Now in part A we have some general question about modulus and graphs related to that. We have to find the maximum point of the graph with this equation. So for the maximum point, 2x minus b should be 0. So x is b by 2, and at that point y will be a. If 2x minus b had any magnitude, it would be subtracted from a and the value would decrease. So it would be less than a. So this point over here is b by 2 comma a. Now they want the point of intersection with y-axis. So at y-axis x is 0. So a minus b, so we'll have a minus b. This is the x value, this is the y value. So this point over here, this point will be 0 comma a minus b. And now in part 3 of this question, we want the points of intersection with the x-axis. So this and this point. So at x-axis y is 0. We'll use that to solve this. So we'll have 0 equals to a minus mod 2x minus b mod. So at first, for the positive solution, we'll consider 0 equals to a minus 2x minus b. Now we have to make x the subject over here. So 2x equals to a plus b, x equals to a plus b by 2. And for the negative, 0 equals to a minus, so we can make that plus 2x minus b will have 2x equals to b minus a, x equals to b minus a by 2. So this point over here is b minus a by 2, this point over here is a plus b by 2. The points are b plus a by 2 comma 0 and b minus a by 2 comma 0. Now in question B we have to draw this function modulus x minus 1. So modulus x will be a graph like this. So modulus x minus 1 will be a graph with a minimum at minus 1. Since this is for 3x, this will be slightly more spread out. Let's just check the roots at first still. Okay, we don't know the values of a and b, so we can just draw it in any fashion we want. So this is the graph of y equals to modulus x minus 1. Now on to part C. We are given that mod x minus 1, and the graph we had before, a minus 2x minus b, intersect at x equals to minus 3 and x equals to 5. So at x equals to 5, y is 5 minus 1, so 4. So 4 equals to a minus 2 into 5 minus b. So 4 equals to a minus modulus 10 minus b. Since this intersection is over here, at this point the modulus sign has a plus before it. So this will be minus 10 minus b. So 4 equals to a minus 10 plus b. Therefore a plus b is 14. And the other intersection is at x equals to minus 3. So y equals to minus 3 minus 1. This would be 3 minus 1, so 2. 3 minus 1 would be 2. Yes. So we'll get 2 equals to a minus 2x minus b. In this case, we'll do a plus over here, and in here we'll get 2 into minus 3 minus b. So 2 equals to a plus minus 6 minus b. Therefore 2 equals to a minus b minus 6. Therefore a minus b equals to 8. So this is equation 1, this is equation 2. If we add them together, so a plus b equals to 14 plus a minus b equals to 8. We'll get 2a equals to 14 plus 8. So 2a equals to 22. A will be 11. And using that, b will be 14 minus 11, which is 3. So that's it for question 8. Moving on to the last question of this paper. It's a question on trigonometry. So in part A, we have to show that this whole equation can be written in this form. So we have 3. I'll just do it over here. We can write 3 sine x cos x like this. So 3 by 2 sine 2x 2 theta. So, and we can also send this to the right. Then we'll have this cos theta plus sine theta. So this whole thing over here, cos theta minus sine theta plus multiplied by cos theta plus sine theta, will get cos square theta minus sine square theta, which is cos 2 theta. So let's just do it. So on the left hand side we'll get 3 by on the left hand side we'll keep 3 by 2 sine 2 theta. On the right we'll have 2 plus sec 2 theta times cos theta minus sine theta times cos theta plus sine theta. We can write this whole thing as cos square theta minus sine square theta or cos 2 theta. the next line will go 3 by 2 sine 2 theta equals to 2 plus sec 2 theta times cos 2 theta. So 3 by 2 sine 2 theta on this side equals to 2 into cos 2 theta plus sec 2 theta. Sec 2 theta is 1 by cos 2 theta times cos 2 theta. So the cos 2 thetas will cancel out over here. We'll get 3 by 2 sine 2 theta minus 2 cos 2 theta equals, we'll get by multiplying both sides with 3 we'll get, by 2 we'll get 3 sine 2 theta minus 4 cos 2 theta equals to 2. This is what we had to show in part A. Now in part B we are given the same formula, the same function. Instead of theta we have x. So 3 sine twice x minus 4 cos twice x equals to 2, and we have to solve it. So we can use r form here. So r will be root over 3 square plus 4 square 5, and then you'll have alpha equals to tan inverse 4 by 3 we'll have 0.9273 radians. So we can write this 5 times sine x minus 0.9273. The minus is due to this sign, this negative before the cos, and this will be equal to 2. So sine of x minus 0.9273 will be 2 by 5. We'll have sine inverse x minus, the basic acute angle basically will be sine inverse 2 by 5, which is 0.4115. The answers are wanted to 3 significant figures, so 4 significant figures is enough. So x minus 0.9273 instead of x there will be 2x over here, not x. So x would be 0.4115 plus 0.9273 by 2. So x is 669 radians. This however is not greater than pi, so we'll have to take other values. This has this equation over here, this line has sine something equals to positive, so we'll take the first and second quadrants. So this will be pi minus 0.4115. We do the same process over here. So pi minus 0.4115 plus 0.9273 divided by 2. We get 1.83. This is also less than pi, so we'll have to make a 2 pi rotation again. So 2 pi plus 0.4115 plus 0.9273 by 2 we'll get 3.81. This value is greater than pi. It's also less than 3 pi by 2. So pi is 3.14 approximately, and 3 pi by 2 is approximately 4.71. So this is the value we want. So x equals to 3.81 is the solution. The next value will be in the fourth quadrant here, so we cannot take that. They wanted it to 3 significant figures, so 3.81 is the answer. That's it for this paper.